Hello everyone, I am Matthew and I will present a brief overview of our work in enhancing shallow neural networks through Fourier-based information fusion for stroke classification. First of all, the stroke is characterized by an injury that abruptly strikes the brain issue. It can be classified into ischemic, which is a blockage of a vessel, and hemorrhagic, a rupture of a blood vessel. The first image stands for the two types of the stroke. The first representation is for the hemorrhagic, in which the rupture of the vessel occurs on the left side. On the other hand, the ischemic stands for the blockage of the vessel. On the right side, we have another image that represents three CT scans from the brain, in which the first one stands for the healthy brain, the second one for the ischemic stroke, and the third one for the hemorrhagic stroke. Our proposed approach, named multimodal Fourier-based RBM, which is the restricted Boltzmann machines, the shallow neural networks employed, propose to represent information in different domains through the Fourier transformation. The use of information fusion for the training of RBMs can successfully be applied to the problem of stroke detection and classification, since the images can be transformed. The first image stands for an example of two inputs in which we have the multimodal RBM based on the Fourier transform. The first RBM receives the original CT scans. Here we have one sample. With Gaussian visible units, we can learn the patterns from the image. The second RBM, learned together with the first one, receives the phase from the same image from the Fourier transform. Both networks learn to detect patterns in the unsupervised manner, and after this procedure, we can fine-tune all the weights of the network with backpropagation. On the right image, we have the same CT image from the brain, in which we can apply the discrete Fourier transform to capture the phase angle from the Fourier transform and the magnitude from the Fourier transform. And these two measures or images, new images, are used to feed the new networks, the multi-Fourier-based RBMs, in which the first one, denoted by P, we have the phase input, together with the Gaussian RBM as the first image. The second RBM, multimodal, with PM, we have the phase and magnitude, together with the Gaussian RBM. And the third one, we have the multi-Fourier RBM with the magnitude from the Fourier transform. In this manner, we have three multimodal RBM with Fourier-based information with fusion to the Gaussian RBM. The results achieved on the given dataset regarding two data splits, which is 50-50 for training and test, and 75-25 for training and test, showed us that the Gaussian RBM achieved the best result overall, and the multimodal RBMs achieved also greater results and better than the baselines from the baseline work. For the second split, with more data, we have the better result coming from the multi-Fourier RBM with phase angle, which stands the higher accuracy, and all the models in bold was greater than the baselines CNN1 and CNN2. Thank you all.